So with our initializer, we need to pass it two things. It needs to have our self and our, actually, no, this is, yeah, our self and our value. So we're going to pass those two in. Give it some parameters. Parentheses, self, and value. Right. So because this is our initializer, it always is going to have self. Okay.
Yeah.
And then anything else we want to pass it. Now, in this particular case, we're making a node, so we just need a value. And so then a colon, and then the next line. Because this is a method within. Ah! Yvette. Put the colon on the outside of your parentheses.
I'm here.
All right. So now we need to pass our, so now we need to assign the value to a value.
So what value is equal to value?
But this is a class. So self.value equals value.
Oh.
Now, because this is a singly linked list, now remember that terrible picture I drew a few minutes ago that now I'm going to draw again for YouTube. Hi, YouTube. So we have these nodes, right? And before we talked about how the node had a value. So the value of self, here's our value, which is give ourselves a value of a happy face. And we also have a pointer. So which would in this case would be self.next. Line 4.
I'm sorry. I was so into your words. And I was
self.next is equal to, so self, nope, we're not invoking anything. Self.next equals none, capital N. Right. So at the moment, with this node, let me clear my drawing. We have created a single node, which is going to be assigned a value, and currently has a pointer that points to nothing.
Why nothing?
Because this is an individual node that goes nowhere. We haven't made the list yet.
Okay.
So when you open up your code signal, you will see a node that says something like this. If you're using a doubly linked list, you might see something, some extra words. But for right now, this is a node and a singly linked list. So our node with our value and a pointer that points to nothing.
Okay.
Everyone clear on that? Any questions? Awesome.
So, I'm sorry. Can I ask you something? So, the line 4 self.next equal none. Does that mean that because it's next and it's point to nothing, so it's equal none?
That's right.
Okay.
That's perfect. Okay, so now we have our node, our wonderful class of node. This exists. Great, we are done with the class of node. So can you go to line 6, backspace so it's even here. And now we're going to make a class called linked list. Make sure it's called linked list, not something else. And I'll make that second L capital to keep Python happy. And now just set up just like node. So colon, next line, define. And what's the first thing we need to, what's the first method that we need to define?
Init.
That's right. Go ahead. Yvette, set it up.
I'm scared.
Doing great.
Don't be scared.
All right. So now in this case, we're just going to have self. So we do not have value.
Oh.
Yes. Just for the linked list, self has no value. Why? Is because this is our list, right? So for right now, we're not passing the list anything. We are just initializing the list as something that doesn't exist. So right now, essentially, a linked list is not an array, but we're going to pretend that it is. We're initializing it as an empty set, okay? So let's go to our next line. Now, the first and last item in a linked list are called what? Does anyone remember?
The head and the tail.
Excellent. So, Carmen, please tell Yvette how to set that up.
Oh God, I don't know how to tell her how to do it.
Self.
Yeah, self is equal to an empty array. Oh. Self.
Dot.
Not head. What am I doing here? Self that head.
Head.
Mm-hmm. And when it's an empty value, what do we do in a class?
Is it brackets? No.
None.
None. Very good. We're setting it to none.
So we have to use none every time.
Yes, for the
Okay.
purposes of this. And what was that other thing that you said we needed?
A tail.
Right. And since we don't have one,
None.
very good. Okay, so what this is initializing, if all we did right now was initialize this linked list, it would spit out, now remember, a linked list is not an array. It is not.
Okay.
You can think of it sort of like one, but it is not an array. A linked list is basically have you guys ever gone to one of those like strange girl stores where they have these balls of where they have these like balls of light on string and they have giant balls? Do you guys know what I'm talking about? Like the paper lanterns? Okay, so a linked list is essentially this giant string of paper lanterns that you put in a basket somewhere. They're all connected to each other, but if you just looked at it, you'd have absolutely no idea.
So just kind of like Christmas lights thrown in a basket?
Pretty much.
Okay.
So we know that they're all connected. They are all connected, but if you were going to look at it, you'd be like, I have no earthly idea because it's not stored neatly in this fashion. And for whatever reason, there you go, my little annotator is being mean. So we have right now, we have a bunch of nodes that don't point anywhere, and we have a basket that doesn't have anything in it. So that is our initializer. We have nothing, we have a whole bunch of nothing so far.
Okay.
So now please go to line 11. Now I'm going to open up the README, because it's going to have the actual instructions. So we need to implement the singly linked list first. Great, that's helpful. I'll tell you anything. Awesome. So now when you add something to the list, when you add something to this list, in general theory, we're going to add something to the end. So how would we add something to the tail? That's going to be the next method that we're going to create. So on line 12.
So I'm not exactly sure if I'm right, but she would add things to the tail by making the pointer point to the tail.
Very
Is that
good.
how she does it? Okay.
Excellent. So go ahead and tab that in because everything is going to happen inside of this class, Yvette. There you go. So define add to tail. And we're going to want to give add underscore to underscore tail because of the tests that they have in this.
Lowercase too, isn't it?
That is correct. They do have a whole bunch of tests in here that you can run in your own time to see how exciting everything is. So now with our add to tail, now we're going to be creating a new node. So in order to create a new node, I need to pass in 2 parameters.
self
Good.
and value.
Excellent, Joanne. So we're passing in self and value. I keep clicking on the wrong code environment. All right. So can anyone remember how we initialize a new class or a new thing of a class? Okay, so we need a new node. Let's call it whatever you wish to call it. We need a new node equals node. So the class node. And what do we pass into the node? What do we put inside the parentheses?
Value.
Value.
Very good. Right. So go ahead and make the parentheses event and pass value into it. So now we're passing the value into the node and it's initializing a new node.
Oh.
Now currently, what does this node look like? It looks like a node. Does it have a pointer?
No.
Not yet.
That is correct. That's right. Not yet. We have to give it one. So we've got to check for some things. I need to stop clicking on the wrong IDE. Hi, YouTube. I'm really, really disorganized. So the first thing we need to check is our linked list. So what if our list is completely blank? Is our right now? What if our linked list contains nothing? It's just an empty laundry basket with no light bulbs.
You could return nothing. You could return.
We're adding to the tail. So what is the tail?
Oops.
What is the tail if we have nothing? So we have first thing we have to do is check.
If you have nothing, then the tail points back to the head, right?
So if
Well, yeah, but if there's no head, then there's no tail.
right. So if self.head is none, that's the code event. If self.head is none.
Is
Yep.
you gotta put
Oh.
I need an if on at the beginning. There you go.
so retarded.
No. Yvette. Control Z. Control Z. Whole bunch of Control Z's. So remember that Python is finicky about white space. So right here where you have self, yep, now just type if space. So remember when we're working in Python, Python is really finicky about white space.
Yeah.
So if self.head is none, colon, what are we going to do? Carmen was getting there. Corey was also getting there. One of you two. What are we going to do? Yvette, colon.
Yeah, basically, if there's nothing in the head and there's nothing in the tail, then you just have to return nothing.
No, we're adding to the tail. So we need
I
to.
keep forgetting that part. It's going to point back to the head, right?
So we need to assign our value. So self
Dot value.
dot head equals what?
New node.
Excellent, Corey.
Ooh.
I'm trying to keep quiet because we did this in morning class.
Very good. And so now we have self.head, but now we don't have a tail. What should we be doing?
Self.head is also a new node.
That's right. Self.tail is also the new node. Perfect. So we're setting our head and our tail to be this node. Now, do we need to assign a pointer here? What do you guys think?
I don't know. I think I'm confused. So if self.head is nothing, then self.head is equal to a new node. What is it? Just automatically making a new node if there's nothing there? Is that what we're saying?
Yes, so we've created the new node and we're trying to figure out where we put it, right? So we're either going to put it we're going to put it either at the end, or we're going to be making a new linked list. So in this case, we've checked and said, okay, well, do we even have a linked list? We don't. Cool, let's start a new one. So we created our node. We're like, okay, this is great. I have a node. Now this has got a linked list, but I'm still pointing to nothing because this guy is currently both the head and the tail, which means he's the only thing in the list.
Oh, okay. I see.
That means that this new node, let me just draw this, make this guy like a little mouse. So our current node's next value is nothing, but he exists. He's in the list and he has a head and a tail. I'm slightly more clever than I thought I was. Excellent.
That's funny.
All right. So then we're going to, as Carmen said, return. Now, we do have a slight other problem because we haven't finished the code, right? So go ahead and give me some new lines. Oh, no. No. Return was where it wanted to be. Now just give me some new lines. We've got to finish the code. All right. No, that's in the same line as this. You want to keep it in the same line as your if statement. So if all of this, now what else? What do we do?
If the head exists now,
So now we definitely do have a head and we have other things. So this one's tricky. Self.tail.next equals new node. Then now the next new line, self.tail equals, you guys are going to hate this. What do you think it equals?
Next. Don't tell me the head. Okay. I was about to freak out.
New node.
Oh.
New node.
Why?
All right. So this is the part that I hated. So now let's look at this list, right? So we've got all these nodes.
Mm-hmm.
And we have all of these nodes. I have all of these pointers that point to things, right? So all these pointers, these are dot next, right? So our current tail, what does this next point to?
Nothing.
Right. So we're assigning self.tail.next to point to the new value of the new node.
Because you're adding to the tail.
Right. And then we're going to say, okay, well, we're pointing to the new value, and now the new value is going to be our new end. So then we just kind of went, all right, cool, and now we're going to put that here. Let me draw slightly better. Does that make sense? Feel free to say no.
So the tail has to always keep pointing to the next node. Is that what we're saying here? The tail has to keep pointing.
So the tail has to point to something. So the first, currently, it points to nothing. So we have this new value. I'm going to make the new value this infinity symbol just so we know what we're doing. So currently, our next value is nothing. It points to nothing. So now we're saying instead of pointing at nothing, we're going to point here. Now, this currently is called tail, but we're not saying it doesn't exist. We're just moving the tail designation over one. And we're saying that this is now the tail. And this tail still points to, what does our tail point at?
It always points to the next node that's
It points
coming
at
up.
nothing.
Yep.
Tail always points at none, unless we're reassigning it to add something to the end of the tail.
And it has to point at none because if it doesn't, then you can't add anything to the end of the tail.
If it doesn't point at none, then it's not the tail, because the tail is the...
End.
Yes.
Yeah. Okay.
So if it points at something, is it the tail?
Nope.
Very good. If it's got something in front of it, is it the head?
Nope.
Clear. All right. So does everyone kind of get how we added to the tail?
Yeah, maybe.
Okay, so so now we're going to add to head. Yvette, go ahead and give me a method called add to head. Yvette,
Yeah. I'm here.
there you go. So what do we need?
Self and value.
Good.
New
Now,
node.
did we have to do the tail first? Could we have done the head first?
Yes.
Okay. Doesn't matter the order. Okay.
No, because these are all methods that live within the class.
Okay.
Do we also have to do the new node?
Yes, we do.
Okay. But it should not be the same, right? The same name. So I
Oh,
would.
no, you can give it a new node. This is its own method, right?
Oh, okay.
Right? So this is its own thing. Every time we're doing this, it's a new function.
Okay, gotcha.
All right, give me a little space between line 19 and 20, please. There you go. So these are all separate functions.
My bad.
All right, Yvette, do it yourself. Let's see how far you can get.
Tail. Wait, it's a tail. Okay, because we already do is none. Then,
Self.tail is always none. Never
huh?
mind. Self.tail.next is always none. Ignore me. Check self.head though. Don't check the tail. That's different. Self.
Head is not none or
Oh.
is exist.
If self.head is none, so we want to make sure that the list is empty. If it's empty, what do we do?
We add a new thing.
Right.
We assign the new node.
What's the easiest way to do all of this coding?
Copy it.
I was told copy and paste is a bad, evil thing.
Yep.
But we're on a time crunch. I got 4 minutes. So now we have this issue here. I need you to fix these 2 lines of code and give me a new head. Do we think that's correct?
Wait, I should. It's annoying me. Oh,
What do we assign here? Who wants to guess?
The tail.
No? Why
the
would we
value.
Ooh. So I got 3 minutes and I'm
Oh, it's
scared.
equal to self. Wait a minute.
Yes, that's right.
It can't equal anything else because it's the head.
So we have self.head.next, self.head.next. So now we want to put something here. So I have a node and I have a pointer that goes to none. So the first thing I got to do.
You have to have a temporary variable to hold it.
We can
No.
do it. We can do it in 2 lines. So
Okay.
self.head.next is going to equal. So here's my next pointer. What is it pointing at?
The next node.
It's the old
Head.
So where it says new node on line 27, it should say
Head.
self.head.
Really? Self.head?
Yep. it makes you want to shoot yourself in the face. Self.head.
Like a light bulb just went off.
All right, and then we're assigning the old self.head value to the new node. So what we did, so self.head.next, so we have a value that exists as a pointer, right? So this pointer of self.head.next now points to the old self.head.
So if you're going to add to the head, basically what you're saying is the old head has to point to the new head.
The new head has to point to the old head.
Or the new head has to point to the old head.
That is
Or else
correct.
you can't add to the
Right.
head. Because it's staying in, so they don't change order. It's staying in line. You cannot
Yes.
change the line.
That is correct. So the old thing, we had to have the old tail point to the new tail. Now we have to have the new head point to the old head. And then we reassign the old value. Then we reassign self.head to be the new node.
Yeah, that makes sense.
Everyone clear?
I
You
don't
have
get it.
Sure that you do the self.head next first before the self.head equals new node. Otherwise, I think that's the reason why we had the placeholder, because we switched those two around.
That is correct. Okay, so we're on add to head. Yvette, do you get that?
No, this part I didn't get it.
Okay, so we have our little list of 3 balls here, okay? So this one we are calling tail, and this one we are calling head. But they exist whether or not we call them that. They're just there, because this one doesn't, the one in the middle doesn't have a name. So these exist on the pointers. That's the best way I can put it. The pointer is what actually gives it its meaning. So when we take our new head, so we have this new thing that we want to put at the front. So this is going to be our new head. But first, we have to give it meaning with a pointer. So this has a pointer that currently, this node, if we look back over here, right, our class of node has a next value. So we're giving this a next value. Self.head right here, right?
Yeah.
Self.head has a value of none.
Yeah.
We have these, they exist. We have our 3 nodes. We're going to pretend we have 3 because 3 is good. This one is just called tail, and this one is just called head. They exist no matter what we call them, and the pointer is what kind of gives them meaning. It links them together in memory, and Harry's got a way better explanation for this, and I don't. So now we have our new node that we want to put at the front. So the first thing we do is we're assigning it to have a pointer value. It's going to be self.head.next. So currently this is self.head.next. So we're taking this away, the head value, and we're assigning this over here to point at the old head. The old heads node also has a self.next value that still points to this. Does that make sense?
Yeah, I think better.
So now we have the old name of self.head. And we're like, no, you don't get to have this name anymore. There's a new prom queen, and it's me. And we move the self.head value.
Okay.
Does that make more sense, Yvette?
Yeah, it's making more sense. Thank you.
Sometimes doing linked list and doubly linked list kind of feels like you're typing the same words over and over and over again, and you start to really doubt your ability to think. At least that was my experience with it. I thought I was going to die. Okay, so now we're going to do the opposite. So give me a new method, and we're going to call it remove head.
They have self, themselves, and their value.
Mm. Do we need a value if we're going to remove it?
What do we need? Do we need the head?
We just need the self, because remember, the self contains, let's be very zen, self contains everything.
Oh, okay. Cool.
Contains
So
42.
we do need, yes. So we're going to take self. Now go ahead and give me the next line. So what's the first thing we're going to do?
No, we don't need the value.
What happens if it's
You
an
need a-
Self.
First thing is our edge case. Self.head if so what if the whole linked list just doesn't exist? What if there's no head node? If self.head is
None.
then what are we going to do?
Just
Just return.
That's right, just return. You guys don't need me.
Mm-hmm.
All right, you're going to want to pop that in one more tab on return there, Yvette. Return goes in one.
You mean tab?
Yep.
Okay.
All right. Now, so now I'm gonna draw a picture, and I want you to tell me how you think we're gonna do this. So we have a list. Our little 3 balls again. I really just like 3 balls. 2 balls and a weird oblong. So this is head. This is head.next. And this is our tail. But what we want to do is cut off the head. And then what are we going to do?
Reassign the head to the next node that's in the list.
Yes. And then let's pretend there's also another one here. Make a little caterpillar.
I was going to say, yeah, then you would have to make sure that the head points to the new node that's coming
To
up.
to the next node.
to the
Right.
next node.
So go to line 24, please, Yvette.
24.
Down. 34. 34?
Oh, 34.
It looks like a 24 from here.
I'm sorry.
It's okay. It's not your fault. You didn't code the IDE. If you did, it would have a much prettier font.
Can I do something like this? Can you see better?
No. Don't worry about it. Ah, yes, now I can. All right.
Okay.
So now what are we trying to do?
We return.
Can you remove the current head before you can't remove it before she reassigns it, can she?
That is correct. So first you've
Okay.
got to do self
Self dot head
good equals self dot
dot
You're creating a point.
head dot next.
yes, that's it. That's all you got to do.
Is this real?
That is real.
Oh my.
There you go. 100%. There you go,
Okay.
Yvette.
What is that?
I don't know. There you go. That is 100% it.
Oh my
That's
goodness.
it. And you absolutely got that logic.
Yeah, I'd be like, is that
Wait,
real?
that's completely it? That's it?
Yes.
What?
Removing the tail
I'm
is harder.
so slow. Oh my gosh.
I'm
that head is
cheating. I
equal to
have my
self
own
dot
code to
head.
look at, so.
Ah.
Now, can you kind of explain something to me, Ava? In
Sure.
morning class, we actually created a data variable at the beginning before the if statement. Sorry, I gotta kill my alarm.
Ooh.
Sorry about that.
You want me to stop sharing my screen so you can share what you want Ava can explain to you so it's gonna be better?
Yeah, I can do that. I'll just hide the bottom code so you guys can't see it yet.
All right.
Okay, I can stop share so you can share what you want.
Okay. You see on the remove head, we added this, but we also added up here. We added a up here of get value.
Okay.
Shouldn't
That
have done
is,
that way too.
it's not necessary.
Okay.
It is completely not necessary. No. That might have been because it wanted you to return some data. It might have wanted you to return the value of the old head.
Okay.
And if that is the case, then that is why you did that. I don't have that in my code. So
Well, I came in late this morning, so I just copied this out of Fatima's.
let me
Why
don't I just let me quickly look at the test. At the unit tests. As I can do that really fast. Yes, that is why. It wants you to have a value. As mine says, none is not equal to 10. So it does want you to have a value there. But for the purposes of just reassigning, this works as intended.
Okay. All right. I was just curious about
So,
that in there earlier.
Yes. So that get value is a great secondary method that allows you to grab that value and save it and then return it after the fact. Super smart. I don't know who, I'm sure Josh came up with that.
It was either Josh or Christine. I pretty much guarantee you that. They're both pretty good.
All right, Yvette, go ahead and throw yours back up on the screen. We are almost done.
Yes. Yes, ma'am.
Okay, so
So this
Here.
was just a linked list. It was just a singly linked list.
yes. So this one is a little bit more complicated. So let's define, remove tail, and then let's get it set up.
Okay. Self, if the tail itself is none,
Perfect.
we
Just
it
return.
should return.
Correct. Excellent. Now this one is a little bit. There is another. There are two more edge cases. So what if there's only one thing in the list?
Well, then it can't point in both directions.
Then if there's only one thing in the list, then we have to. So if self dot head dot
Next.
is
Dot head dot next.
if self dot head dot next is what? If self dot head dot next is none. So that means if self dot head dot next is none, that means that how many items long is our list?
That means it's only one item long.
That's right. So if we're checking if there is no list, and now we check if it's only a one item list. Because if it's a one item list, what do we need to do?
You would need to add a new node.
We're removing.
Oh, I'm sorry.
All right, go ahead, colon, and next line, Yvette. This is supposed to be if self.head, self.tail. We need an if. No, line 38 is an if. If self.head.next is none. There you go. What are we going to do in order to delete both of them? We need to
So the head and the tail are equal to each other here.
self.head equals, how do we get rid of something?
None.
Yep, self.head is none. So we're going to set self.head equals none. But we also need to remove the tail.
Self.tail equals none.
Yep. All right, so those are our two edge cases, right? So we have a empty basket, and now we have a basket, and now we're, whoops, I'm looking at the wrong thing. We are looking at we're checking if it's empty, and we're stopping it. Then we're checking if the basket only has one item in it. Now we have the complicated thing, and this is
So the complicated part you're saying is if we have more than one.
So this is the complicated part coming up. Now we have to do something called creating a pointer. So now we need a new segment outside of our if block. So we're going to create a pointer inside of our function, but outside of the if. Inside the function. Inside the function. There we go. So now give me some space to make Python happy. There you go. So now I need a pointer. Where does the pointer start in a array? We're back to pretending something's an array. Where do we start our for loop?
At the 0 index.
What is the equivalent of a 0 index in a linked list?
In a linked list. Would be what, the head, right?
Right. So pointer equals
Self.head.
Yes. So now we're going to essentially traverse through this little, we're going to kind of traverse through this. So while pointer.next is not as lowercase, self.tail
It's not so.
then how are we going to traverse? Need a colon. New line. How are we going to traverse? I love watching Joanne bite her tongue. She's trying so hard. Pointer equals, what are we thinking? Joanne, spoil it.
Well, I'm actually trying to figure out what you're doing in comparison to the code from this morning because we did ours like totally different. So,
Alrighty, so we're gonna go in a loop. Pointer equals pointer dot
Next.
Right.
Sorry, I know some of this stuff, but I don't want to spoil it either.
Pointer equals pointer dot next. Line 44, pointer equals pointer dot next.
Ooh.
So do you guys see what we're doing there?
Mhm.
We're creating a temporary value of the pointer, and we're moving it through the list. And then when we get to pointer dot next being equal to the tail, what are we gonna do?
It has to stop. Or no, I'm sorry, this is a doubly linked list, so it points back at
This
the
is
head,
a
right?
singly linked list.
Why was I thinking we were doing a double?
I don't
Never
know.
mind.
You have to remove it.
Right, so outside of our while loop, self. So remember, we're reassigning what value here? The tail.
Tail.
So self.tail equals
What? The pointer? Dot.
just pointer.
Oh.
You have to assign self dot tail not next also, right?
Self.tail.next always equals none.
Okay, so you don't have
Okay,
to
why pointer
actually
dot
put that in there.
Nope. No, we do not. The value of self.tail.next always equals none. If we were making a new value of the node, we'd have to set the node to have the value. But in this case, self.tail.next is always equal to none.
Okay, because the reason why I asked is because we put it in there. We actually
All right.
coded.
I do not have it in mine, and mine came from Harry, so I treat that as gospel. I'm always err on the side for me, as I barely understand this. I'm going off my solution code.
You sound like you have a pretty good understanding of all this.
I can read code really well.
Ooh.
I can read it real good. Coming up with it on my own sometimes, I'm a bit stuck.
Well, see, ours is a little bit more compressed on the remove tail, but remove head, we got more.
So this is the easy remove head. This you will actually have to write in code signal.
Okay.
This is I cannot count how many times I've had to write this specific line of code in code signal.
Well, because I think the only difference is we didn't do the checks
Mm-hmm.
for the tail and the head pointer being none. All we did was cursor equals self dot head, which is your pointer. And then we did while cursor dot next.
Ooh, my husband did that one.
He did?
Yes, that was the one that my husband wrote. This one also works.
Oh, okay.
So, just to clarify what's going on here in this block of code from line 42 to 46,
All right.
this means that, so I'm gonna assign the OG pointer to the south head. So why the pointer dot next is not the tail itself? So the OG pointer is gonna be the next pointer. And
That's
then so it's mean that the tail gonna become the head. And also
It means that
the
that
OG
tail
pointer.
is becoming no longer there.
Okay.
Now the thing about lists, because this is operating in memory, right? So this node still exists. It's just that nothing is pointing to it anymore. Does
So
that make
even if
sense?
we remove it, it's still there? I don't understand.
Okay, so remember how I said we have a giant ball of light bulbs
Mm-hmm.
that are like strange lantern strings in a basket?
Mm-hmm.
What we have essentially done now, imagine that we have like 12 strings of lantern bulbs in a basket, and then we gave it to a small child, and the child like messed up all the balls and threw it in the basket.
Mm-hmm.
They're not stored in a pretty line like this.
Mm-hmm.
They're stored like, oh, here's some space here, and here's some space here, and here's a space here, and here's a space here, and this is next, and this is next, and this is next. And let's make it more convoluted, and this is next. And this is the
Mm-hmm.
head, and this is the tail. So when we're changing the node, we're only changing the pointer. We're getting rid of the pointer, we're renaming the tail, and now this just exists in its own little box of memory. The computer will come along later and overwrite that, but we haven't actually deleted it.
Oh, wow. So doesn't that mean that this would take up a lot of memory then when you wrote a program like this? And you're not even really deleting this stuff. It could just exist in your random memory, right?
It gets overwritten.
It gets overridden. Okay, so as soon as we need more space, we just override all of those things that were essentially there before. Okay.
Yes. And this is a data structure specifically for dealing with computer memory. You're not going to write this in a web page.
Okay.
This is computer science for the purposes of memory. And when we start talking tomorrow or the day after about stacks and queues, they used to have limits on how many things could be in a stack and how many things could be in a queue and the length of those things.
Hmm.
That's where we get Stack Overflow from. You can actually Google it and read a cool little story. But these data structures were for dealing with something in a computer memory. It's not necessarily so old that it's no longer useful, but it is really, 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 really old.
Okay.
They're still used, but that is so far above our pay grade.
Gotcha.
So we just need to understand that this is how it works. So we have these balls in a basket with a whole bunch of other balls in a basket, and at some point in time, we just cut this particular light bulb off, but we never bothered taking it out of the basket. And then later on, we're going to go, oh, hey, well, I need this particular cube of space. And then we're going to put something else there. And then it will get overwritten. And that's how that will eventually work. But that's why we're only reassigning the pointers and not doing dot delete like we would in an actual array.
And I like how, I don't know if they explain to you like the actual reason for having the pointers, but I like how the guy in CS50 did it, how he explained the reasoning for the pointers, and basically it helps your computer to run faster using the pointers, because otherwise it could just place them anywhere in random memory.
Just like as we were talking about the basket. So it's just being allocated somewhat randomly, but the pointers, so instead of having to go through like tick a 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 tick, goes, oh, well, that's silly. We want to go boop, 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 boop. Is that clearer? Does anyone have any questions about singly linked lists? This is as far as we're going tonight, so we can get some Q&A in on this.
No, I think that I probably would have to practice writing these a few times though before I could remember them.
Oh,
Yeah.
definitely. Definitely. Mine aren't memorized, but do you understand the theory behind it?
Yes.
Yeah.
Well, not like 100%, but it's getting there.
but like we've moved the needle up a bit.
Yeah.
Okay. So tomorrow we're going to talk about a doubly linked list. Now, a doubly linked list and a singly linked list have something in common.
They
That
all linked.
They are linked. So a singly linked list has a next and a doubly linked list has a next. But a doubly linked list has a
Previous.
previous.
Ooh, okay.
So
More
they're going to point
complicated.
back and forth.